Hi guys, welcome to yet another video of Code from Scratch. So proud of you for showing up today, because if you're able to understand today's code properly, if you're able to understand why are we writing and what are we writing properly, every line of it if you can understand, you will be able to solve so many hard level recursion questions, and not just recursion but also dynamic programming. As we will do more and more questions, as we will practice, you will understand that how recursion and dynamic programming is actually, most of it is just small variation of the code that we are going to write today. And this, I can't emphasize enough on how important this concept is. So please, if you have any doubt in the visualization, in the code, anything at all, please do ask me, because this is really going to help you. So without wasting any time, let's get started. So this is the question that we discussed in the last video. We'll be writing the code for it today. So what was the question? We are given a string S and we have to find all the possible subsequences of the string in lexicographically sorted order. We'll discuss what lexicographically sorted order is, how can we generate it. It's very easy. We'll discuss that later. First, let's write the code for generating all the possible subsequences. So say we are going to store our answer, which will be a basically vector of strings, right, in RES, and this is what we will return also. Okay. Now we had discussed that we'll be writing a recursive function to solve this. So let's start writing that. So I'm just calling it helper. You could call it util or anything at all. Okay. Now what all things will this helper function need? Firstly, it will definitely need the string that we are dealing with, right? And also, what were we doing when we were drawing the recursive tree? We were going through the characters of the string one by one. Like we will first go through A, then B, then C, and then each character we are going to either include it or exclude it, right? So as we are going to traverse through the string, we will need to know that, okay, where am I at right now? Like you will need to know that, okay, I am dealing with the first character, second character, third character, like that. So what am I going to do? I'm also going to pass the index at which I am right now. So basically we will initially pass 0. So that will mean that, okay, I am dealing with the first character. I am going to include it or not include it. Then after that, I am going to be dealing with the first character. I mean, if we see 0 indexing, then B is at first index, okay? Then C is at second index. Like this, we will keep checking for each index, and then we will see include and not include. What else do we need? We could actually pass the size of the string also to, okay, not calculate it again and again, because we are going to need to put a condition. So we can either pass it or we can calculate it within the helper also, that's fine. And since we need to store our result in this RES, we will need to pass that also. And since we will be making changes in this vector, in the helper function, what do we need to do? You should be able to tell this yourself by now. Since we need to make the changes in the helper function, we will pass it by reference, not by value. Why is that? If I pass by value, then a copy of it will be created, and what will happen? The basically changes that we make in the vector will not be reflected. Okay. What are we doing? Since when we are going to call helper function, we will want that, okay, the RES is updated. Basically, we will add our answers in this vector string and we will want it to get updated in the helper function, right? So that is why we are going to pass it as reference. So this is extremely important point. In a lot of recursion questions, we make this mistake in interviews. Interviewers will definitely notice this and they will ask that, okay, is your answer going to get reflected in RES or not? If not, then what is it that you're missing? A lot of times I have done this myself as an interviewer. I keep confusing the candidates. Why are you writing this ampersand? Why are you passing by reference? What if I remove this? What happens? So these small details are very important. So what have we passed till now? We have passed the string that we had. We have passed the index that we are dealing with. We passed the size of the string, and we passed the vector where we are going to store our result. But see, there will be subsequences also that we will be dealing with. So suppose A or AB or ABC. So we will insert those subsequences in the resultant vector. But at a particular time, we will need to know that, okay, what is the current subsequence that we are dealing with, right? So I'm just going to call it maybe like a string current subsequence, or just current, or subsequence, you could call it anything. Basically, this denotes the present subsequence that I'm dealing with. It will be more clear when we write the code. We will also dry run it properly, so don't worry at all. So now for the character at index n, what were the two possibilities? Either we are going to include it or we are not going to include it. So let's try writing that. First, let's try writing the part when we are going to include it. So when we are going to include it, what are we going to do? In the next time when we call the recursive function again, we are going to pass the string, but we are going to pass for the next index because we are calling it for the next recursive. So basically we are going one level down the recursive tree. Okay, we will pass the size of the string. What else will we pass? See, so current was there. Now in this we decided to include the character and index. So what are we going to do? Our current subsequence will basically change like this. So you're going to add the character present at the index. See, this is extremely important to understand because you will see that how small variations of this will be used in the future videos also. In a lot of questions, you will need to understand the exact details of this. So we will discuss this properly, okay? It is very, very important to understand that why are we doing this. Now, after this, what am I going to do? I'm just going to pass RES. Okay, so let's discuss this once more. So basically, what am I doing? I am considering the condition where I'm going to include the character present at this index in my current subsequence. So this was the current subsequence that I had before this index. Okay, so suppose I'm at index 2 when this helper function was called. That means my some subsequence is there for the from index 0 to 1, that is there. Now I am including the character at index and I am passing for the next index now. So this is the include case. It will be more clear when we dry run, so don't worry at all. Then what was the second case? When we are excluding. So when we exclude, what happens? We are going to call the function. We are going to pass a string. Again, we are going to call for index plus 1. We are going to pass the size. Since we are not including the character at this particular index, we are not going to do this. See, because this is string, we can just do plus to concatenate it. See, here what did we do? We just added the character at that index. Here we are not doing it. Basically, we are just ignoring the character present at this index and we are moving ahead to the next index by doing index plus 1. Don't worry, we will try run it. It will be clear. Okay. So we have written our recursive calls. But as we know that we need to end this somewhere, we need to stop our recursion, we need to add a base condition. Otherwise, what will happen? Stack overflow will happen. So how will we add a base condition? Where do we need to stop our recursion? See, when we call the recursive function for the first time, we'll be at index 0. Then we will call it for 1. Then we will call it for 2. Then it will be for 3. When we reach the index 3, basically when we reach index equal to n, basically there is no character present over there. So if we do s of index, it will actually be wrong, right? Because it will be null over there. So we need to stop our recursion over there. We can't include or exclude because there is no character left, right? So that will be our base condition and we'll have to return from there. So what do we do when index becomes equal to n? Basically, we have gone through the indexes 0 to n minus 1. Now we have reached over here. So we need to end. So what are we going to do? We are going to return from here. Now notice this, we had passed this vector result to store our result in this, right? But we actually never made any changes to it. So what do we need to do? We need to add our possible subsequences to this resultant vector. When do we add the subsequences? When we are sure that, okay, we have finished creating the subsequence. When do we finish creating the subsequence? When we are in this. We will talk about this, don't worry at all if it's not clear right now. So what am I going to do? I'm just going to push back the current subsequence in this and I'm going to return from here. Let's dry run this and let's see that, okay, why this is going to work. So the first time when we are going to call this helper function, what are we going to do? We are going to pass our index 0 and our current will be basically empty. Our subsequence will be empty and our result will also be empty, right? So now what we will do, so we have not reached index equal to n, so we are not in if condition. So we come to this helper and we are in the include condition right now. Okay, so we are in the first character. So we are over here. We come to the include condition. Now what happens? Our current now becomes equal to current plus s of index. So current was initially empty. So now current becomes equal to what? A. Okay. And what do? We from here again call for index equal to 1, right? So because initially index was 0, now we call for index equal to 1. Now what do we do from here? We call for, so our now current becomes equal to a plus s of index. So basically it becomes ab. Now we call it again. So we come to this include condition again. Why are we going inside only? Because we have not finished executing this. This exclude part will get executed only when we are done executing the include part. So earlier we were calling like helper of this. Then from there we are going inside. Now again from here, now our index value will become 2. And from here our current value will actually end up becoming ABC. So we are still in this part only, include. Now what will happen when we come over here, our index value now becomes equal to 3. So that is when we realize that, okay, our current has become ABC and we put it to RES. So now our RES becomes ABC. So ABC we have pushed it. Okay, so our current value was ABC. So now this include has been executed for what index? So here index was 0, here index was 1, here index was 2. Then we called for 3. That this is where when we pushed into res. So when we went back, so basically we executed this and we went back. Okay, so when we went back, now we are done executing the include condition for index equal to 2. So now what we are going to do, we are going to do the exclude part. So in exclude part, what will happen? S was there, index was still what? It was equal to index was 1. So 1 plus 1 will again be 2, and current value will actually remain AB only. Why is that the case? Because see, here we were passing current plus S of index. That is why it became ABC. But here we are passing AB only. So current value will remain AB and there will be no change in res. So basically this is the exclude part. We did not include C, we excluded C. Okay, so that part is not there. So again from here we call for index equal to 3. We come into this condition and then we see that okay, we have reached our index equal to n. So now what happens in our res, we add the current equal to AB also, because current was equal to AB. Now here we return again, and now here current value becomes equal to again 1. Okay, so we are done executing the include part for index equal to 0. So now we come over here and what do? We get into the exclude part. So here exclude part will be what? So current was 0. So now we are calling for index equal to 1 only. But now because we are at this level only, okay, right? So index will be equal to 1, but our current value will be what? It will be equal to A. So we are at current equal to A. See here index became equal to 1, but we did not include B. So this is the exclude part, right? So we did not include B, that is why we are over here. And now what do? We call from here. So basically we will call for index equal to 2, but B was not included. Now B was not included. So what we will do? We will check, okay, C has to be included or not. So when C is included, so basically we come over here. Now index is equal to 2, because from here we have gotten inside this. Now from inside this we are calling for index equal to 2. Now our current will become what? So it was A. Then we add S of index. So S of index is what? C. So we add C to A. So that is why current becomes equal to AC. Okay, so now when we call from AC, we again call for index equal to 3, and then we see that okay, we have reached index equal to n. So that is when we will pass current to our, we will push current to our res. So basically we push AC also. Now we go back from here and then we have to do the exclude part. Exclude part means what? We are going to exclude C also. So here we were already at excluding B. Now we are excluding C also. So basically our current actually remains as A only. So now since current remains as A only, from here we will again call for index equal to 3. And when we call for index equal to 3, we will again go back and we will push this current to res. So basically we will push A. Now we will go back. From here we will go back, because see, we are done executing the exclude part also. So if you have any confusion, let's quickly summarize also. So we started from over here. So over at this level basically index was 0. At this level index was 1, 2, 3. The index passed I am talking about. Okay, so when we passed at index 0, we included A. Okay, and this is the case. Now once this include tree is done, once this entire tree is done executed, that is when we will go to the exclude part. Okay, so that is, we are still in the include A part. So when we include A, then from again there are two parts. First we go to the include part, because what is happening? We are calling the include again from inside. So then we include B at index 1. Then we included C. Then we came over here, then we saw, then we went back. Then we went back. Since we have come back, now we are doing the exclude part. Then we came over here, okay, base condition reached, we went back. So the visualization should be extremely clear. You should be able to understand, okay, that how we are traversing the tree. First we came over here, we reached the base condition, then we are going back, then we are going back, then we are going to the exclude part, then we are coming over here, going back, then again going back from here, Now when we come over here, now we are going to do the exclude part from here. So basically this is what? This part is exclude B. So this part will be exclude A. This part is exclude B. This part is exclude C. Okay, if it is still not clear, this part was entirely include A. The part that we are going to write over here will be exclude A. This part over here is include B. This part will be exclude C. This part is include C. This part is exclude C within the functions. Okay, that is why. I think now it should be clear. I want you to draw this part of the tree yourself and let me know if you have any doubts. So basically what you will be doing, you will be starting from excluding A. Okay. So basically what you will have to do is you will deal with exclude A now. So basically your current will become equal to empty only. So from here now you will include B, so your current will become equal to B. Here your current will become empty because it will be that. Then from here you will be going to include C. So basically it will become BC. When you do exclude C, it will become B only. From here when you do include C, it will become C. When you exclude C, it will become empty. So if we see the level at this, basically it will become 8, and when you reach at this level you will end up inserting these to your result. So basically that is why in the end your result will have 8 current subsequences. Okay, I hope this is clear now. I hope you have understood this code properly now. Let's finish writing our code and let's compile and submit and let's see. So this is the RES that we have to return. So let's do our first helper call. So what are the values that we will pass? We'll pass the string. Our initial value of index was 0. We will pass n, which is the size, right? So we are going to calculate s.size. See, I prefer calculating size and returning it. Otherwise, what you could have done, you could just not pass this and you could have just written index equal to s.size. But that depends on your style, whether you want to do it or not. Then current initially will be empty. We will keep adding the characters to it as we saw. Then we are passing our RES value in which we'll be making changes. So now we have the answer with us. We have all the possible subsequences. But now there are two catches. One catch is that we have to return the answer in lexicographically sorted order. Now let's try to first understand what is lexicographically sorted order. Basically, if you were inserting all of these subsequences in dictionary, how they would come, that is called lexicographical order. So basically in dictionary, A comes before B, then B comes before C, you know that. So on all the possible subsequences that we saw, so if this is the order, you can see all the subsequences starting with A are before. And in A also, the ones with B are before. So AB, then empty is considered to be the first one, right? So A, then AB, then ABC, then AC. Because C is bigger than B, that is why it is coming later. Then all the subsequences starting with B, then all the subsequences starting with C. So basically you have to sort the vector. So whatever answer you have, you just have to sort it. So in any question, whenever you are asked to answer in lexicographically sorted order, all you have to do is just sort and return, because strings by default get sorted like this only. So what will you do? So we have our answer in RES. So basically we will do res.begin and res.end, and that is it. So this is the first catch that we had to do. There is one more catch to it. I wanted to pause and think about it, okay? And I really want you to tell me in the comments whether you noticed this second catch or not. So pause and think about it. There is one thing that we are missing. So what is that one thing? See, what are the number of subsequences that we had? They were 8. And what are the number of subsequences that are there? That are 7. Why is that the case? We had discussed this earlier, that in this question, they are not including empty subsequence. But when we calculate the subsequences, when we do the recursive tree, if you saw the rightmost element that we came, when we went down the exclude part, basically you exclude A, you exclude B also, then you exclude C also. So we'll end up having a subsequence which is empty. So when you go through that, you have to remove that from your answer, because right now your RES will have 8 elements and you want only 7 subsequences. You have to remove that. Okay. Now the catch is that since we have sorted that, we know that where it will be. Where will it be? What did I say right now? That empty comes before anything else. See here, AB comes before ABC, right? Because the character after B is sort of empty. That is why it came before C. Similarly over here, A came before AB. Why? Because it is like A plus empty, right? So that is why it is coming before. So in sorting, so when we had our 8 subsequences, the first subsequence that would have been there would have been empty. So all we have to do is we have to erase the first element. So how will we do that? res.erase, and we will remove the first element. So first element, what is the iterator pointing to the first element? It is res.begin, and we have to erase only one element. After this, there will be 7 subsequences in this example, okay? Similarly, over here also, since there are 2 elements, we would have had like 4 subsequences in this RES. And then when we sort, the first subsequence will actually be empty. So we will erase it by using this. Let's compile it and see whether this runs or not. So this has compiled. Let's submit it and see. So yes, this works. The question that we are going to discuss tomorrow is actually a very small variation of this, but it is very, very interesting, and you will be able to understand it only if you were able to understand this question properly. And you will see how most of the questions that we are going to discuss now, hard level questions, will actually be variations of this. So I hope you are liking this series. I hope you are finding it helpful. If you are, then please do share it with your friends, because it will mean so much to me. Even they can join us, they will study with us. I will feel so motivated. So please do that for me. It will mean so much. Thank you. See you tomorrow.